I get up, time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. Finding life along the way, melodies we haven't played. No, I don't want no rest. Echoing around these walls, fighting to create a song. I don't wanna miss a beat. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. And we'll grow in number, fueled by them to see the horizon, turn us to thousands. And we'll grow in number, fueled by them to see the horizon, turn us to thousands. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go.
Open eye, feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies, only you can make me move. You can make me move. Can make me move.
Yeah, hello. I should be audible now. Just please let me know in the comments if voice is fine. Audio. Is it correct now? Please let me know. There was no mic. Please. Should be fine now. Please let me know. Cool. Yeah, okay. So welcome everyone. Welcome to the stream. Today we are going to be discussing classes. And before starting classes, we'll talk about object-oriented programming and why are we talking about object-oriented programming and why are we taught object-oriented programming, right? And what are some key things behind object-oriented programming, and also take a look at structures, where we left structures and how classes extend structures in C++ and give us more power and functionality, right? So we'll take a look at that. I'm not sure how long we'll be able to cover it, but like I'll try to cover structures. I'll try to cover classes and OOP and basics of OOP, and then we'll talk about some things about OOP in C++, like data abstraction, data hiding, polymorphism, whatever all the 4 pillars of OOP are, right? That's one thing. And probably I'll try to solve some problems if there are time. Otherwise, we'll continue maybe tomorrow, right? So let's talk about structures first, okay? And then so let's talk about where we left with structures, okay? Yeah. Okay, so as we all studied that in structures, we had basically the ability to combine a few different types into one single type, right? So let's say thing is, we started treating entities like, instead of like, let's say for example, a student composes of many things, right? Let's say, which is the int study current year, current underscore year, let's say then string register number, right? Let's say string DOB, let's say an array of subjects, right? So subjects, right, being taken in this semester, and so on. Let's say 5 subjects. So student becomes an entity for us, right? And we treat and with structures we are able to handle them very nicely, like encapsulate all these all these different data types into one compact structure where we can refer it. So that's why it's called a structure, right? A compact representation of different data types that we have. So things are good with structures. In C we saw that we could pass structures to the functions and so on. But if you see, there are some problems with structures, right? I'm specifically talking about structures in C. In C++, structures are so close to classes, so we're not going to talk about that. We're specifically going to talk about structures in C, and then we are going to jump to classes in C++, right? So if you see, student has all these fields: current year, registration number, date of birth, and list of all the subjects and so on. But any part of our code or any function to which we pass this structure can operate on these, right? It can operate on these, like it can change the current year, it can change the registration number, it can change the DOB, it can change the subjects, right? If we basically pass it by, assume that I'm passing everywhere by reference, right? So it can change everything, it can change things, right? So let's say in a certain case, student's registration number is always fixed, and we choose an external library written by a student. A student wrote that external library, and we are using that in our code. And what that student is doing is, in his function, he's expecting that the teacher who will be using my library to make a program will pass this student structure in an actually running production database server. There, I'll just modify my marks or subject marks or something like that, and we are passing everything by reference. Since I told you to assume like that, we have no way, we don't have any control. If we are having structures in C, we don't have any control over, like, okay, I'm going to pass you only these certain data members of this structure, or only these certain data members of the structure will be visible to you, right? We don't have any control like that, right? So that's one problem. we do not have like data hiding is not there, right? So data hiding is absent. Okay. Then also what we have is, so in C, if you write, let's say you have a given, let's say, let's take a complex number, for example. Okay, another case. So you have a complex number and you want to add another complex number to it, right? So you have a complex number, let's say a complex class, or let's say complex structure for now, which stores an integer real part and stores an integer imaginary part. Okay, so so real and imaginary. Now if you have to add two complex numbers, what do? The general approach is to make an add function and pass the two complex numbers to it, right? So pass the two complex numbers, let's say complex C1 and complex C2, right? And then this function does whatever it wants to do. The logic to add two complex numbers, right? So what happens here is, this function is external to my all the structure of complex, right? And this function still needs access to these private public, like what I'm saying is this real and imaginary is still accessible to this function, and this function is external to my structure, which in some cases I may not want, because I'm not sure if this I do not want my external functions to access everything in my structure, right? So that ability structures in logic, like we cannot have structures and a function inside a structure, right? In C we cannot have that. And I mean, let's say if we had functions inside structures, the way to write code would have become beautiful. So let's say we could just do C1 dot add C2, right? We could just call like this. So add would be a just for representation purposes, I'm showing like that. So we could simply do C1 dot add C2, and C1 would contain the addition of C2. Like if C1 is 1 plus 2 iota, if I add 1 plus 3 iota, the result would be 2 plus 5 iota, directly stored in C2, rather than making a C3 and C3 equal to, let's say, add C1 comma C2, right? So the code becomes a lot better when you have these kind of ability to store functions also inside your structures, but which is not allowed in C, right? And also one more thing. So let's say you have a hierarchy of, let's say, vehicles, right? Let's say a vehicle. What is a vehicle? A vehicle is a machine that has, let's say, 4 wheels, not even 4 wheels. It has some number of wheels, it has some number of seats, and so on. It has some properties, right? Now a car is a special type of vehicle, a truck is a special type of vehicle. So these hierarchies, something is common, right? A vehicle has an engine. Let's say a vehicle has an engine always, right? Any machine that has an engine is a vehicle. Let's call that. A car is also a vehicle, a truck is also a vehicle, but they differ, right? They differ in terms of power, they differ in terms of seating capacity, they differ in terms of pulling capacity, and so on, like torque and everything. That kind of hierarchical mapping is hard to do in case of in structure. So let's say I make a structure for vehicle and I put some basic properties of vehicle in that structure. Now if I need to, let's say, make a structure for car, and I need to have those already existing properties in vehicle in my car also, I'm just left with nothing but to copy those properties manually from vehicle and then put them in my car also, and this results in a lot of repetition of code, right? And repetition of all those methods that are used for that. That is one problem that is solved by OOP, and that is the term and the what's the word for the term and the basically it's called inheritance. And with inheritance, what we do is we are able to model these relationships of hierarchies in our code itself. So we'll learn more about that as we see. I'm 100% sure inheritance or something. I'm not sure if you guys are already aware of inheritance or not, but we'll take a fresh look at everything. Not inheritance probably today, but I'm basically trying to motivate you guys to go for OOP, since I also started with structure and C and then C++, and when I was in my first year, C object-oriented programming was something like something new to me also. what is it? Why is it called object-oriented programming and so on? So we'll understand and we'll see how beautiful it is. And just a disclaimer, I don't work with C++ regularly. I mostly work with Java. So Java is a complete object-oriented programming language. In C++, even if you don't create an object or anything, you can still write code. But in Java, things are like start with the class. So everything starts with the class, right? So that's a pure object-oriented programming language, but we'll come back to that later. So again, so we talked about data hiding, like I can hide certain things, which is not possible in structures. Then we talked about like, so structures are a way to abstract what's being happening. What is abstraction? Abstraction is something like providing, what abstraction is a very simple concept, right? So let's say, okay, so Google search, it's doing a lot of things behind it, right? It's crawling web pages, storing everything in the database, whatever you write something, it just quits. But what a normal user sees, that text, that search bar, right? That Google search bar is where you type something. That's an abstraction over all of the complicated processes happening behind it. You type it, you get the result. So that's an abstraction. Right? So similarly, if you see in our programming languages also, like these structures or classes, these kind of provide an abstraction over all the logic that is required behind the scenes to manipulate the data or anything. So if you have a structure for complex, you're hiding all the logic of storing, how you're storing a complex number and everything, right? So that's abstraction. Then we talked about inheritance also, like modeling hierarchies. Then we talked about encapsulation, which is hiding the data basically, right? And then the last term is polymorphism, which is the fourth pillar of object-oriented programming, which we'll not talk about it now because you'll understand it later. But just to give you a small idea, let's say we have vehicle. Okay, again coming back to our normal hierarchy of vehicles. A vehicle has a horn, let's say. Okay, a car is a special type of vehicle, has a different type of horn. A truck is a vehicle which has a different type of horn. Now let's say you have a function in your vehicle class, right? That is let's say play horn. The name of the function is play horn. Now your car, when it is also type of vehicle, when we call play horn on the car and we call play horn on the truck, we know that both of them sound different. We are assuming that we are not going to put a truck's horn inside a car. So we'll have a car horn and we'll have a truck horn, right? So when we call play horn on a car and we call play horn on a truck, then both should sound different, right? So this instead in a hierarchy, when you have different things which are hierarchically modeled as a similar thing, that one function acts differently in different different places, right? So that is what is called polymorphism, like different functionality in different cases. So these are the four pillars of OOP: abstraction, encapsulation, inheritance, and polymorphism. Hope that is clear. What is like these are the four pillars and what are these four pillars. Please tell me in the chat if you have any questions, or if I confused you with anything. You are feel free to put your questions in the chat. Also during while I'm talking, also chat is in front of me. So if you put any questions, I'll be more than happy to answer them. So take a few minutes and please post your questions in the chat if you have any, and if I confused you anywhere regarding all these four pillars, because you should just remember it's a very popular interview question also, like what are the four pillars. And if you're able to explain these four pillars to anyone, then yeah, you can say that okay, I at least grasped the basics of OOP and what's the reason behind object-oriented programming. And then we'll dive into name, like why object-oriented, right? So please, if you have any questions, put them down. Otherwise, we'll continue. Can you make beginners videos for C++? By beginners, what do you mean? Like, what other topics do you guys feel like you have problems understanding? Beginners, because in beginners, see, there are a lot of things. I can make beginner videos based on if condition, for loop. So you're gonna go that beginner level, or you're gonna go to level like taking problems and solving in C++, like how to think of a problem, break it down into the small problems and then solve it. What's the level that you're looking for? Point. Okay, I don't know why still people find pointers very difficult. Okay, we can I think if Premnath, I'm not sure if you checked out the structure video, but I did, like, we did come up with our fear of structure pointers, and we did pass around structures by reference and by pointers. So we did that. So don't be afraid of pointers. See, the only way to conquer pointers is by solving more and more problems. So if you want, what I can do is I can maybe let's solve some problems and we'll only use pointers to, like, we'll pass everything by reference and we'll use pointers. And then, yeah, so I see a lot of people ask me, like, you should discuss problem solving in C++. Cool. So we can, that's what I mean. So the thing is, learning a language is different. See, learning classes and everything is fine. But how do you strengthen yourself? How do you strengthen these concepts is only by solving more and more and more in problems, right? So the POD, I hope if you all who are watching this, if you don't solve POD, make sure you solve POD. And do not, like, if there's a POD which can be solved without using classes, and if you have just learned classes right now, why not try to make class, and if it's possible to model it as classes, why not make it as a class and then solve it rather than just going away. See, POD is not meant for any competition or anything, although there is a rank list. If you can solve this problem without using classes or anything, you can do it faster. So POD is meant for you to learn, right? When I give some complicated problems, then I expect, okay, the first one to solve was he was able to think it through very good. But generally speaking, POD is meant for, improving your problem solving skills. Okay, so yeah, okay, problem solving in C++. Point taken. I'll discuss about problem solving in C++. So let's say, will it be possible tomorrow? Let me know, guys. Is it tomorrow a good date for discussing problem solving in C++? Like, what I'll do is I'll take up some problems which I really like, and we'll break them off over in the live stream so that we can interact also and solve it. What do you say? Is tomorrow a good day? But today we're going to discuss object-oriented programming. Today we're not going to digress from the topic. So, is tomorrow a good day? Why not? Like, let's spend Sunday. Anyway, we're in lockdown, we are at homes, and the COVID situation is very bad out there. So why not spend our Sunday, learning something new, solving better problems in C++, right? I'll try to take up problems from this Code Chef or Code Force, and I'll also guide you. I would love to guide you guys to how to start competitive programming to strengthen your problem solving skills. And if you guys there are various things to talk, like ICPC is there, n number of things are there to talk about, and I'll be more than happy to talk about it tomorrow. Yeah, sure guys. Then tomorrow, I would like if you guys come tomorrow. Let's do this at around 12 or 1 p.m. only tomorrow. I'll schedule it off. And tomorrow, let's talk about problem solving. There are very nice things to talk about problem solving, and it makes me nostalgic when I talk about problem solving, because it's one thing that I used to love in college, and I love it right now also. Whenever I get some time, I sure go to Code Forces or something and try to solve some problems. Although I have forgotten many things, but yeah, but college is really the best time to solve problems and make your problem solving skills better. Again, enough talk. We'll talk about this tomorrow. Let's come back to object-oriented programming. So yeah, so OOP, right? And some people call it as OOPS. Oops, I don't know, object-oriented problem solving or something, but what is it? So the thing is, let's say we have, coming back to our C, right? So in C we had structure, right? And we called structure as a user-defined data type, right? So we call, let's say we make a variable of type student. We call it student, let's say S. So this S is of type student, which is a structure, right? Here, what we do is, in object-oriented world, it's kind of similar, but with more fancy things. So similar, if you define a class named student, and when you make a variable of type student, that variable is not called of type student, it's called an object of type student. It's called an object, right? So how it happens is, why is it called an object or something? So we need to understand what a class is, right, first, and then we'll come back to what an object is. So we are clear with what structure is and how we use structure to define types, right? So let's come back to our classes. So what are classes? Classes are also like structures. They're just blueprint of a data type that we want to introduce on our own, right? But instead of just being pure containers of data types, they also can contain methods and constructors, and they can hide some data. They can have methods also, and so on. So classes are like structures, but with a lot of power, right? Classes are like structures with a lot of powers, right? So and when you use this blueprint to create a variable, so when you create another use that you'll see is instantiate. When you create or instantiate a variable of this class, you get an object, right? And what we talk in OOP is these objects, they contain data, right? And we use methods that are provided by class to operate on that data. And this is how somewhat contributes to object-oriented programming. In that, everything is a class. Everything is a class. Like everything can be modeled as a class, and then you make variables of that class, basically calling them objects. You instantiate, you create those class, you create those variables, and then whatever methods you call those objects, you call on those objects, basically change the behavior or change the state of the class or mutate data and so on, right? And that's it. That is what object oriented programming is basically. Now I'm 100% sure there would be like better ways to explain this. I kind of went directly in the code, but I hope you're able to understand what I'm talking about. So classes are nothing but structures with a lot of powers. We create or instantiate a class and we get object, right? This object has all those methods with these class has. So class is just a blueprint. It just defines, okay, if you create an object, these are the things that that object will be able to do, or these are the things that that variable will be able to do, right? So enough talking. Let's let's dive into code and let's see how classes look in real life, and let's see. Okay. Okay, so let me make a file called intro classes.cpp. Okay. So let me just include so this is a header file which is available in GCC generally, not available everywhere. So what I'm going to do is, let's define two things. So let's define a structure, okay, like C type of structure, and we'll do type def, I think. Okay, so let me just check one thing. So we'll have, let's say, struct, okay, student, okay, and let's say a student has a string register number. We are using C++, so we have string data type as well, right? And string registration number. Then we have, let's say, int class number. Okay, let's say we have string name and so on, right? So this is a structure. So this is a structure, and if I go to my main function, let's make a structure of type student. So let's make a variable of type student, student s, and let's say s dot reg number equal to 15 PC1283. Okay, I'm gonna copy this and make s dot class number is equal to, let's say, 1283, and s dot name is equal to, let's say, Shubham. Okay, I'm gonna do right, and let's just see out s dot let's say, yeah. So now what we're gonna do is we're gonna print a student, right? Let's say we want to print a student. So since we are coming in C, and I'm not gonna do what C++, one sec. Yeah, so C++ allows us to add functions also inside the structures, but again, we are coming from C, we don't know what C++ structures are, right? So let's say we make a function to print. So void print underscore student, right? And let's say it gets a student. It gets a student, right? And then it does see out s dot name, s dot reg number, and s dot class number. Okay, and I'm gonna do an endl. Okay, and let's say we call this. Same thing we'll do using classes, and you'll see how interactive and how good it becomes using print student s. Okay. Start reg number. So is it like, do you need type def here also? Doesn't need std string. This is C++, right? I hope I am not making any mistakes here. Okay, type def. Let's add a type def as well. Okay, so it still complains us. So okay. The reason is, okay, so we have not added using namespace std. Everything is inside this namespace, right? So I'm going to remove this type def and I'm going to check if C++ structures work without doing a type def. Yeah, now it compiles. I forgot to give a space here. Okay, I'll give a space. Is the font visible or is it too small? Please let me know. Okay, yeah. So if you see this, this works, right? And as I said, so with structures, the only problem is we don't have the ability to, you know, add methods inside the structures and so on, right? So let's rewrite this code and make it as a class, and we'll make this code look a little better, right? Instead of making a void function, like a function out of the scope of student, why not make a blueprint where a student is a self-contained thing that we can invoke a print method on, and it will print the details of a student, right? So let's make a class. So the way of making classes, class student, right? Similarly struct, but like we just write classes. So class student, okay, semicolon behind. And then let's say these things, registration number, class number, and name, are something that we don't want external world to modify or see, right, directly. So we're gonna make them as private. So another, yeah, object-oriented programming thing coming into the picture. We are able to encapsulate our data, right? So private, let's say string register number. Register number is private. Okay, let's say our class number is private. Okay, and let's say our student's name is also private. We don't want to allow external world to directly see. It's a good idea to always have private data members in a class. Okay, I'll tell you the cases where public data members are also okay, but generally in my experience in Java, how much I've used, data members of a class should always be, so these are called, I did not explain, so these are called data members. The members in the variables inside a class which contain the data are called data members. Pretty much self-explanatory. So what you do is, a good object-oriented programming pattern is, you should, and you know what, OOP is not something, is the only way to program in this world. There are various other, OOP is just a style of programming. What you learned in C, was it anyways close to OOP? No, you did not think in terms of objects or anything like that. You were just like this, that was just called procedural programming. You just make functions, you just work on things and so on. There is another paradigm called functional programming. So there are different paradigms of programming. Object-oriented programming is just one type of paradigm. Okay, so a good approach to problems, solving problems using object-oriented programming is always have your data members as private. Never make them public, because we don't want direct access to data members, unless obviously you're doing a small example. And you should give public accessors and mutators. What I mean by that is, accessors is the functions that would allow you to access those variables. Mutators would be the functions that would allow you to change those private variables. But when you have, when you give those methods, you have the control. You can check if people are changing things or not, right? So let's say, so I'm gonna make a method string get registration number. Okay, let's call this a string get class number. Okay, or let's say I'm gonna get underscore class underscore number. Let's use this snake case. So get underscore reg number. Let's make this function and then call it get underscore class underscore number. And as I said, if you keep those data members private, you also get the ability to you also get the ability to extend only few things to the user, like make only few things visible to the user. Now the user cannot directly change the registration number. User can only get the registration number, right? If you give a method like, let's say, void set underscore registration number. Why void? Because this method does not need to return anything. This method just sets the value, and let's say it takes string registration. Okay, so let's do. So we have we'll have, let's say, string. So yeah, so this is also a good approach in C. This is specific to C++ only. So what you do is, again, coming back, declared a class named student. We make all the data members private. Generally, this is a good idea. Always you make public methods available to basically work on this data, right? You do not expose the data directly. You make methods. Why? I'll give you one more example for that. So let's say we did not have this string class. Okay, and let's say a person gives us name as a let's say as a string in double quotes they give us. So in our get registration number, we can implement the logic wherever we want, however we want, right? Rather than if a person directly sets registration number, they might not know what's the type of this registration number. Is it a character array or is it a string? So that might lead to error. So when you provide accessors and setter, these are called getters and setters. If you provide the users with getters and setters, you are in control of of how they access the data and how they change the data, right? So that's why this is a good idea. So yeah, coming back. So in C++, what we do is we just define our functions in the class. We just declare it and we define it generally outside the class. This is how I was also taught, and this is how I follow in C++. But in Java, everything is inside a class, so you anyway declare everything where it is, right? So I would not do like, so if it were Java, I would just do string registration number, write the logic here itself, but will not do that here. Okay, just a second. Okay, so let's just define these methods. Okay, so student, let's say, and the type of the data type, the return type of the method is string, get underscore registration number, and this returns, let's say return, let's use our, I'll come back to this, but again, I'll simplify things by using this pointer. So return this dot, I know a lot of you, do you guys find this pointer difficult? You don't understand what this pointer is? Please tell me in the chat if you find difficult what this pointer is and what it is. Meanwhile, I'll just complete this. Student. Because I see that my brother really found some problem with this. What do you think is better, C++ or Java? That's a good question. But I'll tell you what, I prefer C++ anytime when I have to do problem solving. I prefer it more than Java. But none of them are bad language. So C++ is faster than Java. I find C++ kind of easier to write while doing problem solving rather than Java. Java is more verbose. So that's what I work in Java, because Java is like widespread across industry, and Java has like the way you write code in Java is very expressive. In C++, code becomes very cryptic very easily. But in Java, methods have full names and it's a very verbose kind of language. So by verbose, what I mean is it's self-explanatory. The code is very self-explanatory, and it's easy to manage, and it's easier to find Java libraries, and it's easier to work with Java. With C++, you have a lot more quirks. Like Java has automatic memory management as well, which C++ does not have. So more power, more responsibility. With great power comes great responsibility. Anyway, I don't know. I don't think you guys have problems with this pointer, right? Very good. I don't see anyone saying I have problems with this pointer. So int student, and then we have, let's say, string student. We have this method called get class number, get register. Okay, I defined this. What is this? String get class number 2 times. It should be string name, right? String get name. Let's define get underscore name. Okay, and return this name, right? So this name, this class number, this registration number, and let's see what happens if I don't define this method. Okay, I'm also not sure. It says string has not, sorry, string capital S. This is not Java. Where else am I doing this mistake? No, right? So yeah, so if you see the code in our main function, it puts s.regno equal to this. So it says is private within this context, is private within this context, is private within, cannot be, can be accessed via this method, is private, declared private. Print student was not declared, so print student is anyways not there. Okay, so that's how, we are getting the power of controlling what data the user can see, right? And then let's so if you not define this method, it's fine, nothing goes wrong, it's an empty. So right, so let's make a method called print student as well. So let's say void print, we'll just call it print. Okay, and notice how while calling this print, I don't have to pass a student object into it, because this is now linked to an object. This method is now linked to an object, right? So that object has this method. So class is just a blueprint. Whatever these data members are and these methods are there, when you create or instantiate an object of this class, you get those methods on that object as well. So let's say we have, let's say, void student colon print. We'll get to that what this colon is, right? I hope a lot of this scope resolution operator, but we'll see what it does. So we have student print, and let's say we want to print it in a very nice way. So see out this, let's say, so we don't use this pointer directly. We do see out get registration number. Why to repeat code, right? When you already have a code written. So get registration number, get name, and get class number. Very nice programming. This terminology is dry. Don't repeat yourself, and you should always follow that while writing code, right? So let's say, so we cannot modify things like this, right? So s.reg number like this, right? So let's make setter methods like this for this. So let's say, so as I said, getters and setters, obviously always a good thumbs up for that, right? So set registration number, set class number, and this will take an int class number, right? Because integer is the type. Int class number. So with structures, you could see that we could directly just set those things, right? But in classes, we get more fine-grained control over those data members, right? So I am. You'd also wonder, like, why was the need for classes? Why was structures are already fine, right? So these are the reasons. Like, anyone can access and change the values at any given time. Is bad. I mean, it can lead to unpredictable circumstance in the code. Let's say somewhere in the code someone changes the value of a variable and it was being used somewhere else also, and because of that the state of the application changed entirely. These kind of things have happened before, and that's why these are the techniques provided by C++ or any programming language, to safeguard against those those problems. So we have set registration number, set class number, and then we'll have also what, set name, and let's say string name. Let's define these methods as well as quickly. I'm just going to do void student set reg number. Oops, Java habit of putting S capital. Java has this weird thing where everything which starts from S should have capital S. I don't know, because it was made by Sun Microsystems, that's why they have done this, or I don't know why, but yeah. So we will do this dot name equal to this dot reg number equal to reg number, okay. Right. And then I'm just gonna copy this and I'm gonna just change. So set regno and then set class number, and then I'm gonna int class number. This dot class number is equal to class number. So see how I'm using this pointer here, because the variable argument of this function that I'm passing, the parameter name is also class number, and inside my class, if you see, the data member is also named class member. So in order to avoid that confusion, I am using this pointer. So tell that for this particular object, set the value of class number equal to the class number given to us, right? So it's to avoid an ambiguity. Otherwise, there's no necessary reason to use this pointer, right? And this dot set registration number, set class number, and then we have set name, string name, okay, so name and name, right? So we have setters defined, we have getters defined, we have a print method also. So now let's do, so again, this code, will this run? It will not run, right? Because it will tell error that it's all private and it's not accessible. So let's just do, so again, so let's make a student S. Let's just do right now, let's just print student, let's see what happens. Okay, so let's say I'm going to call s.print. It's allowed? Yeah. So it says 0. What happened? What happened? Why is it 0? Can anyone tell me in the chat? Why did it just print 0? What happened to registration number, get name, get class number? What is this 0? Can anyone tell me? Like, anyone has any idea? I defined S. Okay, in structure, if I would have done this, let's say, okay, let's just try this out with structure also. Okay, so I'm just going to comment all this class file code, and then I'm going to just do struct student, print student, right? So I'm going to make a student S of type student, and I'm going to call print underscore student of S, right? And let's just run it. So here I get a random value. If I run it again, I get another random value. What is it? What's happening? Can anyone tell me? So if you take a closer look, like let me just show you. So we have a struct student, we have a print student. Same logic, the print statement we have in our structure code also. We just see out everything. What's happening? What's going on here? I get 2 empty spaces and then a random number in case of structures, and in case of class I got 0. Any ideas? Internal constructor. I don't know what a constructor is. Can anyone tell me what a constructor is? Harikesh, what is a constructor? Oops. Mistake here. Oops, print student. I just. I'm gonna call s dot print just to show you guys once again. What is a constructor? I don't know. I haven't talked about constructors yet. So what is a constructor? And is it because of the constructor? Okay. Anyway, I'll explain. Nothing to worry. So in the class might be initializing the data members. Yes, correct. And that is what constructor does. As the name suggests, constructor, it constructs the object. Constructors creates and initializes the data members. Correct. Yeah. So if you see with structures, the only problem is we did not have the ability to initialize these things, right? Let's say I want to make a student object with registration number, this class number, this name, this. I had no option, right? So I had to make these methods like, set registration number, set class number. I would need to pass a structure inside that and it would set those values. In classes, we have this concept of structures, and structures are like functions, but they run when an object of that class is created. So what happens is, what happened here is, I did student S. Okay, so let's say we are the C++ compiler. How we interpreted this is okay, so I'm in the main function. I see this student. What is this student? Okay, let me just find the definition of this student. Okay, so this is student class. Okay, what this user is trying to do, it's trying to create an object of S. Okay, so in order to create an object, I need to call a constructor. Do I have a constructor? Oh no, the user has not given any constructor. Okay, then I have to pass my own default constructor. The constructor passed by the compiler itself, the internal constructor, is called the default constructor. So if you don't pass anything, what the compiler will do is, it'll quick chup chop, silently, it'll not tell anything. It'll just pass a constructor. So student, and it'll do something like this. I can even use this pointer inside it if I'm not wrong. In Java, I hope it works here also. This class number is equal to 0. Like initialized values. String is by default blank, and name is equal to this blank string, right? Hope this works. I have not made a blunder by this. Student is a private within this. Student. Okay, sorry. The constructor is okay. I haven't talked about this. I'll not do this. Garbage value. You're correct. It's garbage value also. I'll tell you. So again, you see 0, 0, right? But this time this value is in our control. So coming back, why was this C value giving us some garbage value? So it depends on compile. It's kind of a thing like here. In case of classes, the compiler quietly inserted this kind of constructor inside our code because we did not give it. So what it does is, for string, it knows that the default value for a string should be blank if anything is not given. Class number, like it's an integer. Okay, I assume that the default value of an integer, if nothing is given, I'll take it as 0. And name, okay, this is another string. I know what the value of default string is. It's a blank string. Okay, so I'll make it as blank, right? So this is what it does. It makes this, it inserts this. So even if I comment this, compiler will not complain. I'll say, okay, if you haven't done this, the people who have created me, they have taken care. I know you would make this mistake, so I would do this on my own. I would insert this default constructor for you, right? So this is one thing that it's called constructor, and this is what happens when you write this line. And now if you call s.print, this is what happening. The default values are initialized, and then this is the class number becomes 0, and this is what is printed, right? So now let's do some. Let's just do s dot set class number. Let's say 1 2 3 4. Okay, 1235, let it be. S dot set a registration number as, let's say, 15 BC 1283, and let's say S dot set name, let's say, I'll again use my name, Kumar Shubham. Okay, and now call S dot print. Compile the code again and run it. So you see 15 BC 1283 Kumar Shubham 1234 1235. Everything came properly, right? So now, don't you see that this code looks a lot better? I'll give you another example of, we'll solve that program of, we'll make that program of adding two complex numbers using C++ classes, and we'll see how elegant the code looks versus how it looked with structures, right? So let's do that. Any questions still here? And then we'll jump onto that, and then you'll, I think, appreciate the beauty of object-oriented programming more. So you see how we allowed these values to be private, and again, I mean, we accessed, so whatever was mentioned in the class is just a blueprint for the object, so the object gets everything. We'll talk more about different things in future, but any questions still here, or any doubts, any confusions, feel free to post them in the chat. Don't think anyone is going to judge you or anything. We are here to learn, right? We're not here to be afraid of asking. Even if it's a very small doubt, feel free to put that in the chat. If I was rushing through anything, feel free, please. So class is simply private, public. Again, yeah, so I did not talk about these. What are these called? Access modifiers, if I'm not wrong. Okay, could you please explain this one more time? Cool, sure. So a lot of people have this problem with this. They tend to feel like, what is this? Okay. This is literally this. This is literally pointing to the current object. So, and there is absolutely no reason to use this. This is used only when, cases like this where the same data member is available inside the class as well as, the same argument is taken. So I'll tell you what this is. So let's say I'll do one thing. I'll make a student S1. I'll make a student, let's say I make a student S. I'll make a student SA. Okay. Let's say we're going to do void. Will it work? Let's, okay. Anyway, so we have these two objects, okay, S and SA. So let's just dry run into the code and let's see what happens. So when I call s.setClass number, let me just call same on SA as well. Let me call sa.print. Okay, sa.print. Oops. Yeah. Run the code. So we just get the class number. That's all. We get the class number, and other things are blank. So we get a space and then correct. So let's talk about what's happening. So we declared two student S and SA. So as I said, what's happening? It's going to the constructor, right? What is the constructor doing? It's initializing everything to the blank and the default values. And then we are calling set class number 1235. Okay. So on S, when we are calling set class number, so let's say where is S? So set class number, right? In that case, I'm calling this class number. Okay. At that point, this points to S. I mean, whenever I write this, it's always in the context of the calling object, on the object on which I'm being called. So if I'm calling any function with S, I mean, I'm doing S dot set class number, it means that inside this method, whenever I refer this will always point to S. I think we can try that also, right? Let's try it out. So what we're going to do is, let's try it on. Let's see if it works or not. If it doesn't work, then try to answer why I'll try to find why it doesn't work. So what I'm essentially going to try is, what we'll do is, let's try to print the address of this pointer, and let's try to print the address of the object also. Let's see what happens. Okay. I am also not sure what's going to happen. I'm doing this for the first time, but let's see. And if everything goes correct, it should be same. But if it's not same, I think then there's a different reason for that. We'll try. Let's see. So void student, let's say get this address. Okay. What I'm gonna do is, so I need to declare this in the class also. So void get this address. Okay. get this address. Okay, and then I should be able to print cout ampersand this, right? This should print the address. Okay, and also I'm going to call s dot, let's say s dot c class get this address. Okay, get this address and cout ampersand s. Let's see. I hope it works. Who knows? Oh, this is a point. Okay, ampersand L value required as. Okay, does it not directly work like this? Okay, I think then. But okay, okay. Or what we can do is we can use printf. Printf. What's the way to print address? Percentage. Let me just quickly take a look at that. So percentage p is the format specifier. Okay, so let's use percentage p comma ampersand this. Let's see if this, or this is a pointer, right? I think does this anyway. Let's do this ampersand s. Let's see what happens. Okay, I think then this is, what does it say? What's the error? So L value required as unary ampersand operator. It says the left value is required. Ampersand. Okay. Okay, let's just do one thing then. This is a pointer. I'm just trying out things if it works. Very good. Ah, yes. So we've got it, guys. Yeah, so this clears my confusion as well, as I'll tell you guys what's happening here. Why was that not working? And let me just use this printf call here as well. Ampersand s. Okay. Oops, dot slash a dot out. And let's just print it in a new line. So backslash n. Compile it again. I'll tell you what's happening. Okay, very good. So if you see, so again, I'm coming back to this. As I said, this is a pointer, right? So at any given point, this points to the object on which this method was called, right? So this is a pointer, so we dereference it to get the actual object where it is pointing, and we print the address of that. And I also print the address of s, right? And these two addresses should be same, right? So when I run this program, do you see that these two addresses are same? This clears the confusion why this is called this pointer, because it always points to that same memory location where it was called, right? So if I say, let's say sa dot get this address, okay, and I do printf percentage p comma ampersand sa, these two should also be same. I think I should do a backslash in here as well. Yeah, so if you see this 307F0, 307F0 and 307A0, 307A0. So this pointer and this pointer always points to the object on which it was being called, right? Shridat, I hope that clears what this pointer is. It's nothing but a simple pointer which was given for the ease of access and ease of naming these variables inside this. So you see how I did not know about this, how it did not make it work. But again, I was not afraid. I was still, curious to see if it works correctly or not, and just quickly Googled what's the way if I print the address and why the compiler error was coming, right? So since it's a pointer, we just dereference it to get the actual memory location of the object to which it points, and it's the object from which that method was called. Is it confusing, or do you guys find it? Is it clear now? Please tell me in the chat if you still find it confusing. I'm ready to explain it once again. I mean, in a more clear manner if you want. What do you say? Is it confusing or is it okay? Okay, then I don't see anything in the chat, but you can put it. Okay, it's clear now. Cool. Okay. I think there's a latency. That's why I see the chat messages later, but it's fine. Okay. Yeah. Okay, I was just turning on the AC. It's a little too hot for my computer when it's streaming. So yeah. Okay, so let's come back and let's actually use classes to solve a better problem which was not able, which with structures the code was not satisfactory. Let's add two complex number. A very simple problem, but again complex. And then we'll talk about a few more things, right? Static data members, const data members, and what they are and so on. But first, bear with me. I have to for everyone it should be easier to understand, right? So. And also in between, just make sure to like the stream and subscribe to the channel if you haven't already, because we want to make an army of people who are just good with C++ and don't see people everywhere are teaching high level data structures and everything. But what I want to focus on is that you should be able to get started with problem solving. If you start with basics right, then again learning data structures or anything in future is easily possible. So make sure to like and subscribe and always share it to your friends if you find it useful, so that we can just get more people and just spread all this good. Because see, again, the situation out there is so bad, it's just heartbreak. So why not, when we have this time of being at home and doing things possible, why not create things? So I mean, this is one very common question which we all are software engineers, right? But the COVID situation out there is so bad. A single engineer like me, I always wonder, what can I do? What can technology do to solve those problems? What's going on out there? People need oxygen beds and so on. Why can't we make an app? Why can't we make a website that can give people access? And if you see out there, people are actually doing this. People are using Twitter hashtags to find all the verified data and put it. So I mean, you're at home, but these things should motivate you. You're at home, but software engineering is a kind of thing which you can do from any place. All you need is a laptop and you need to know programming. So that's what we are doing here. We are strengthening our basics. This channel is all about that kind of motivation. So we'll do that. We'll continue to learn things and we'll build better things in future. Yep. Again, so let's start with the class complex. Let's call it complex. So I follow this idea of naming the class with capital letter. This is a very common ideology in Java, which I follow here also, so that I can do like, so it's used to like complex. I can do like this. So that's why capital letter. But again, let's say, so we're gonna make private. So there are three types of access modifiers. I did not talk about it earlier. Private, public, and protected. Okay. Right. And so these three things have different definitions. So private data members are members which are only accessible to the objects of this particular class. That's all. Objects created of this class are only able to access these private data members. Public, as the name suggests, accessible to anywhere out of the world. Protected is accessible to classes which are inheriting from this class and as well as to its members. So this is a little bit, it's not always used, it's used in certain cases. I'll tell you like a use case for this. Okay, so what happens is when you inherit something from, let's say, okay, so forget the word inheritance or something, I'm gonna tell you. So we talked about the vehicle class, okay. In that vehicle class, it has a method, let's say. So let's say for example, I'm gonna show you. So class vehicle, class vehicle. Let's say it has a method called in a protected field. Protected. Okay, and the method is void play horn. That's something like this. And right, play horn. Let's say a class car. Oops, the spelling is wrong, right? Class. Let's say a class car inherits from vehicle. This is the syntax, if I'm not wrong. Yeah. So, but I'm not going to talk about inheritance. So let's say a class car is inherits from vehicle, and by saying inherits, we mean a car is a vehicle, is a type of relationship, right? So car is a vehicle. So when it inherits from it, it also gets a void play horn function, right? Play horn function, right? So since it has inherited it from the base class, which is the vehicle. So I mean the class from which we inherit is called the base class, and the class which inherit is called the inherited class, and so on. But again, I just quickly wanted to show you guys. So this play horn, right? And then it can implement the play horn in the way it wants, and that is what polymorphism is, right? And protected. So coming back to what protected is, so if I declare this as protected, the inheritors, the classes which inherit from vehicle, can also access this method. If I would have made this as private, and I would have tried to use play horn here, it would not have worked. We'll talk more about that when we discuss about inheritance. Because honestly, I also need to refresh on C++ inheritance because I don't use it as often. So anyway, coming back. Private, public, protected. It's clear. Any questions, feel free to post them in the chat. Nothing to be shy of. So let's make our real numbers. Let's make the real part and imaginary part as private. So integer real part. Okay. Integer imaginary part. Okay. And when a user asks us for when a user asks for a real number, we should also give the user the ability to get. So int get real, right? Int get imaginary, right? Let's make a method to print also. So void print, and let's say we have print, and let's say we have a method to add, right? And it takes another complex number. Okay, very nice thing. This is what the power of object-oriented programming, how encapsulation and abstraction work together. Like, so add, I can just define inside this complex class itself, which was earlier not possible with structures, right? And let's just define these methods now. I've declared these methods, so let's just quickly define. So what I'm gonna do, I'm just gonna copy all these. Oops. Yeah. Okay. Let's just define. So int, these are in the complex class. So this scope resolution operator is nothing but telling me that define this method which has return type int inside the complex class which has the name getReal, right? If you don't supply anything towards the left, it always tries to find it in the global scope. Global scope is anywhere outside those curly braces. Simple. Outside these curly braces, any code is written that's global code. Okay. Okay. So in complex get real. So just return this dot real. Right. See, I can also not write this when it's not required. So return real. Then I define this. So int complex. And I'll just quickly give you a quick peek of something else as well. Just stay tuned. So imaginary. Okay. Print may we'll return void complex. Oops. Yeah. Complex print return real. So let's say string sign. If string sign is equal to, let's say if our imaginary is greater than 0, greater than equal to 0, then true, then sign becomes plus, otherwise sign becomes minus. I'll show you what I'm doing. So see out real sign. Okay, so a sign is not needed. So if one thing, so I want to print my complex number as 1 plus 2 iota or 1 minus 2 iota, right? So if the negative number is there, then we'll do if imaginary is less than 0, then we just do cout real space imaginary and then do iota. Okay, and then else we also need to put sign as well, right? Because plus numbers will not have sign plus by default. So cout real, we'll do plus here, and then imaginary iota, and then okay. So this is done. Okay, yeah. So this is done. So print is implemented. Now let's implement the add function to add two complex numbers. Okay, complex add. So if imaginary, oops, no. So complex. So see, we are getting another complex number and we have to add it to the current complex number, right? And the result will be added in the current complex number. Where is our current class pointed by? It's pointed by this pointer, right? So what I can do is I can do this dot real plus this dot real is equal to this dot real plus c dot. Now is the real part public? No. Then I have to call, is the real data member public? No, right? So I have to call the get real method, and that's how I use it here. So get real. Okay. Oops. Yeah, so I'm just gonna copy it. So this dot, and then imaginary part also becomes this dot imaginary plus c dot get imaginary. Understood? Is it confusing? Please tell me in the chat if this is confusing. Right, so we implemented everything. So let's do one thing. So let's make two complex numbers, complex C1, and let's make a constructor also. And now let's give a constructor which can take let's say real and imaginary parts. I'm going to do complex, and it can take, let's say, int real, int imaginary, and it can do this dot this dot real equals real, and this dot imaginary equals imaginary. Okay, so complex constructor is there. So I'm going to call C1 1, 2 and C2 2, 3, let's say, right? And let's do C1 dot add C2, right? And then let's do C1 dot print C2 dot print. Okay, and let's just, before addition also, let's do C1 dot print and C2 dot print. Let's just make some spaces. Okay, so yeah, so let's take a quick look at this code and understand what's happening line by line. Okay, so what does the compiler see? Compiler sees, okay, complex has been called. What is this complex type? I don't understand what complex is, so it will try to look up, is there a user defined data type which is a class? Okay, I found what complex is. Okay, what are you trying to do? You are trying to call complexes constructor with the 1, 2. So do I have a constructor which takes 2 integers? Oh yeah, I do. Okay, then I'll do whatever is supposed to be done in this constructor. I've done that. I've made 2 objects, and now you're calling print on that C1. So when you call C1 print, it will print the values of the data members inside C1, right? And that's what's gonna happen here. So let's just what's the name of the file? G++ -10. Oops. ++-10 complex.cpp. If you see, so we defined as 1 + 2 iota, 2 + 3 iota. After addition, it becomes 3 + 5 iota, and then we have printed C1.print and C2.print. Something is not 1, 2, 3, 4 lines are there. We have, okay, so I have not saved this file. Let me, G was not declared. Where is G? Okay. Evidently I made a mistake. So we have 1 + 2 iota, 2 + 3 iota, 3 + 5 iota, and 2 + 3 iota. 1, 2, 3, 4. Yeah. So four print statements, 4 things printed. Hope this is clear. How elegant the code looks. See, so you're in structures. What we were doing is we would have declared a structure, and then we would have C1 dot real equals something. Oops, not like this. Something. Let's say SA, and then we do C1 dot imaginary. You know, the code, you are dealing in terms of abstractions like complex, but you are still defining those members in your main function itself, right? But how elegant the code looks here. You call the constructor with the values here. It gets initialized. All the logic is self-composed inside this class, right? And that is what abstraction is. I need not care of what's happening inside the class. I'm getting the value. Right. So any questions? Any questions still here? I hope this is working fine. Okay. Anyway, if you have any questions, feel free to post. So now let's talk about something else. So we have these kind of data members. Okay, this print function. Okay, this print function. This is fine. Let's say we have a method. Will it be suitable? So I'm going to talk about static data members now, right? Let's talk about static data members. So what are static data members? So the keyword static in C++ in terms of classes is put on any data member or any method, and that method or that data member belongs to the class and does not belong to the object. What I mean by that is, let's say let's say we define a static integer number of instances. Very nice example. Number of instances. Okay. Hope this works. I'll have to check and compile and check. This is not allowed, right? Non-static method. Static. We'll have to static number of instances plus plus. Okay, let's do that and let's see if this. Okay, so this does not work like this. Okay, then I think. Okay, anyway, yeah. So static data member, what are they? They are part of class. Okay, so this static int number of instances. Now this variable number of instances does not belong to object. This belongs to. So if I do, let's say number of instances equals, let's say 1. Okay, and let me just compile this code. So does it not allow me from number of instances reference from? Okay, I think it does not allow me to. Is it like this in Java? It's not like this in Java, right? This is a C++ specific thing. But what would be a good way to explain static? Let's say we have static int count. Okay, let's do one thing. I'll define something. I'll do something else with the complex class. So what I'm going to do, I'm going to do complex. I'm going to define this as complex underscore static.cpp. Okay, and we're going to do something. So we're going to follow a pattern, very popular design pattern, which is to basically not allow creation like this, right? Let's see. What we're going to do is we're going to make a method. We're going to make a, let's say, a static method. Okay, I'll tell you the difference. So let's say for now we have a I'm going to do a static get or create, and it's going to take int real, int imaginary. Okay, static, and it's going to return a complex number type create, return complex of real comma. Okay, so till now our knowledge was, so again let's to refresh that. Let's say we call c1 dot, let's say we call complex. Okay, this is our complex. Let's say complex, we call complex dot print. Okay, let's see what happens if we run like this. It works. What is this? Shouldn't have worked, right? Complex is a class which does not have static. Wow. Okay, so this is new for me. This I did not expect it to work. Okay, then I think I need to take a better look at this before explaining to you guys. So I think this is a little weird, because I'll tell you what. So static method is a method which is part of the class. It is not part of the instance specifically, right? So basically what happens is you can call a static method directly from the class rather than making object. So if you see, what I wanted to show you was that c1.print works when I have to, like, when I call it on c1, but if I call directly like complex dot print, let's say like this, so I'm calling it on the class, right? It does not make sense, because class is just a blueprint. But I don't know, somehow it still okay, I think I was making, okay, sorry, my bad, I was compiling it as in the old file. So it says, okay, so let's just do one thing. My mistake, very good. So if I do like this, it'll tell me cannot call member void complex without object. Listen to the error message carefully. It says cannot call member function without object. If I make it an object and call print, then it's fine, right? So if I make this, so again now, but I have a static method which is create. So I'm going to call complex create, and then I'm going to do 1, 2. and this gives me another complex number. So complex C3 is equal to complex create. Let's do C3 dot print. Okay, let's just do one. Let's just 4 comma 5. Yeah. So if you see, I created a method which is static. I just defined it here itself, but you can define it outside also. So this method now belongs to the class. Other methods, like if you see, if I do complex get real, this will not work because it will say that, okay, this requires an object. This only works on an object, right? So it will not work. But if I do C3 dot get real, it will work. Cout C3 dot get real, okay? We just compile it. We'll just run it. So if you see 4, so this is what static members are. Now, a lot of people, I hope this is clear. Whatever mess I made, I hope I cleared it out correctly. So please feel free to post your questions in the chat. We are here to learn, not to be judged or anything. We're not afraid of asking doubts, right? Okay, so again, a lot of people get confused by the fact that, okay, so if this is static, why don't you do something like, can we modify these values inside here? Real, imaginary. Can we? Anyone in the chat? What do you guys say? See, if I do, let's say, let's say I do return real, let's say real equal to 1, and let's say imaginary equals to 2, right? So what will happen is, let's say, and that's all. Let's make this as a void function, and let's call this function as change, and let's make it as let's say, what I'm gonna do is, I am gonna do let's say an int let's say new real, and let's say new imaginary. Okay, so we'll do what we'll do is, we'll do real is equal to new real, sorry, new underscore real, and imaginary equal to new underscore imaginary, right? And I'm gonna call, let's say, so this is still static, right? So I'm gonna call complex. So I'm gonna call complex change. Okay, I'm gonna pass 1 comma 2. When I compile this code, what's gonna happen? Is it gonna throw an error? So again, I'm gonna tell you. So what I'm doing is, I have these two complex numbers. I give complex : change 1 comma 2. And so let's say we define C1, and after, let's say this, and then let's say complex C2 3 2 comma 3. Okay, so I've defined a complex number C1 1 comma 2. I'm gonna change it to 5 comma 6. I run this code. First of all, tell me, what do you understand by a code like this? And is it gonna throw me a compile error, or is it gonna throw me nothing? It's gonna work perfectly. So if C1 is gonna change to, if C1 is going to be changed to 5 comma 6, 5 plus 6 iota, what's gonna happen? Can anyone tell me in the chat? Come on. Does this make sense? The method is static. Okay, so I'm able to call it on the class. So I'm passing 5 comma 6, and it's actually changing the real and imaginary values. What's gonna happen? What will happen? This basically checks your understanding of what objects are and what is static and difference between that. It's okay if you're not able to answer it right now because you're getting confused. I'm there to clear that confusion. But this example will 100% clear your confusion regarding that. Anyone in the chat? What's gonna happen? Compiler or no compiler? Just yes or no. Yes for compiler, no for everything is gonna be fine. And if compiler, then what could be the compiler? Okay, anyway, I don't see anything in the chat. Then no compiler. Okay, let's compile this code then, Satish. Let's see what's gonna happen. Whoa, what do we get? What's the error? Invalid use of member in static member function. Invalid use of imaginary in static member function. Right, and C3 was anyways not declared. So where is C3? Yeah, so C3, let's remove this. Okay, so again, please understand this carefully. A lot of people have confusion. This, by the end of 4th year also, people tend to just cram this up, but you don't need to cram this up. This is a very simple thing to understand. static data members or static members, static functions, static data members, they belong to class. If we define setters in public, we are actually providing access to manipulate purpose of putting the data member in private. Okay, Sridhar. But this function is actually not able to change. It's actually not able to change the values. Correct. What you said is correct. We are providing setters for data manipulation, but this function will not work. This code will not compile. Why? Because, okay, now understand why I told that static members belong to the class, and these data members without the static qualifier belong to the objects. They do not belong to the class. They are just blueprint. When you instantiate or create an object of a class, then they get alive. Okay, so see. So the thing is, if you see static void change, this method is a class method. Inside this, you're trying to access a variable which only comes alive when this class is instantiated or created, right? When the constructor is called, basically. So inside a static method, which belongs to the class, so what happens is static method can be called anywhere, right? You don't need to make an object. So these real and imaginary will not even be defined, and you are calling change method on the class. What are you actually doing? Does this make any sense? That you are calling a static method to change the values, but those values are not even defined yet, because an object is not even created. I created an object C1 and I'm doing complex : change. What is this? I'm changing the value in the complex class. Does the complex class mean anything without any object of it running? If I call, like, let's say something like C1 dot change 5,6, how much more sense does it make that, okay, you're calling C1 on you're calling change on an object, and that an object is what is an actual running instance of a class, right? So what you're doing is you're changing the value 1 from 5,6, but where? What are you changing? Nothing is defined. How are you even changing it? And that's why when you are inside a static method, you cannot access the normal data. Why? Because they are not part of the class. They are only part of the objects. Only when you create an object of this class are those particular data members accessible, and that too only to those objects. Class has no role. Class is just a blueprint. So these static methods are just a way to give methods to the class which are always present on the class. They are not present on the object. I mean, they are present on the object, but they are specifically meant, and they are also called in Python, they are called class methods. At the static method, there are class method. Exactly. So whenever you declare anything static, it becomes a part of the class. Okay, it does not depend on an object and the state of that object. So when you say complex : change 5,6, it just, I mean, if you get that feeling, you'll just immediately say, what is this? What are you even doing? You're calling change 5,6. Inside that, you're accessing a real and imaginary when they don't even exist yet. They don't even exist because class there is no definition. The object has not even been constructed. When the object gets constructed, then only real and imaginary get values. Do you understand? So inside a static function, you can only access static data members, because then let's say if I do static and let's say starting string class underscore name, static string class name. Got Satish. Okay, so that's why, I mean, since static belongs to the class, and if you are accessing static things inside a static function, then only that makes sense. If anything is not given as static, you cannot access it inside a static method. And again, please don't get confused. I hope that is very, very clear that, inside a static method, only static things can be considered, because it depends on whatever is available inside the class, not inside the object. And these real imaginary are initialized only after the constructor is called. But since change is a class method, it does not depend on the constructor being called. It does not depend on the objects. It depends on the class. So if these static real and imaginary were static variables, then this code would not have complained us, right? So if you see, I'll show you one thing. So Okay, let's make this static int real, static int imagine. Let's compile this code. Undefined reference from this. We should initialize static data members outside the class, I guess. Okay. Okay. Thank you for telling me that. But again, this is private, right? Okay, so I think I can make a setter static void set underscore real. Okay, and let's say I'm going to call int real static void set underscore imaginary int imaginary. Okay, I'll tell you, this code is still very wrong. Again, so like how we learned that normal variables cannot be accessed inside static functions or static context. Similarly, if you're calling this int get real, right? If you're not created an object, you cannot call this get real, right? Because this is not a static function, which is not available in the class. Simple. So let's just do static void complex set underscore real int real. Yeah. Or can I just simply okay, since these are static, I can just directly call the, but okay, so real becomes 5, 6. Okay, let's run this. But the only problem is that this gives me some weird compilation, complex change, get real, not found in architecture. I think it's been long and I'm 100% sure I'm doing some mistake with the static, but I'll probably look it up and then explain to you guys tomorrow then. There is something, and I don't want to teach you wrong things. So anyway, but yeah, whatever I taught, that static, it belongs to the class, and if you don't put static, it belongs to the object. You should always remember that, and there's nothing to cram it up. Hopefully, int complex real equal to outside the class, etc. should work. But whatever, the thing is, this is private, right? So I don't think other than class we can outside the class we'll be able to access this also. Private data members can be set using setters or the constructor, right? I mean, it's been long, so let me just check static member function in C++. Let's quickly. What? Okay, it works. Okay, it's public, right? Private will not. Okay, so what I think is then private data members will not make sense. So let's make it public. Okay, so I have an example. Then a better example would be so it worked in other code in okay, I'll show you. I think it should not work here, but let's try it. So int real. Okay, let's make this all as what I'm going to do. I'm going to make a method called static. Let's say static number of instances. Okay, and I'm going to make it as an integer, right? Okay, whatever. Let me just remove this static method as. Let me remove this static method also, and I'm going to do number of instances plus. So my goal here is every time a new object is created, I want to increment this count. I want to find out how many number of instances are created at any given point of time, right? So I can create a method also for this. So static int number. So let's say static int get number of instances. Okay. Let's say I'm just going to put it here. It says return number of instances. Okay. Since this is a static function, this is a static variable, I can access it. But I have to initialize this to 0. And as Satish is saying, int complex should work, right? So let's try it out. So what I'm going to do is let's say I'm going to do complex. I think this should not work, because then what's the point of it being private inside a class? So complex number of instances, let's say make it as 0. Okay, and let's remove this call. So we make two complex numbers, print so let's say print cout complex And we call the static method on the class itself, not on the object, right? Because they are class methods. You can call them on objects also, but there's no, like, it does not make sense. Let's call this method. So complex get number instances. All right. Wow. 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 So I get to learn something new. It works. Even if it's private, it does not it did not make sense to me. But thank you, Satish. It's nice. Weird. But okay, then I get a doubt that how can this work if it's a private data member? What's the meaning of private? Is it only valid for the objects which are part of the the non-static variables? That's a good. I think I'll look it up and then tell you guys. Maybe if you guys know, you can tell me. We are learning anyway. So if you see, I got that complex get number of instances 2. So if you see, I created two. If I create more complex number, let's see, C3, C4, C5, C6, I will get as 6. So I created 6 instances. I can count the number of instances created. And that is what static member functions and static variables are. I hope this is clear. There's no confusion between static. The only thing I'm confused about is how can private static members, how can private member static variables be accessed outside? Okay. Okay. Okay, so I'm reading some on the internet. It says, see if you guys also want to see it, I'll just share with you guys also. So the person has raised the same doubt, right? When a static member is declared private in a class, how can it be defined? This was my doubt, right? And then see, the people have replied that in the very same way as you define a public static variable in your source file, access specifiers will not give you error while defining the member. Access specifiers control the access of the member variables. Defining a static variable is an exception which is allowed. So this is kind of an exception, which is a little bit weird for me. Which is really weird for me. I don't know why it works, but it works. I mean, everyone has done that. Only they have initialized it outside, but then how is it private? I want to understand. This is weird because in Java, if things are private, it's just private. So is this again one of the static public? Is there a private static? Exceptions are weird. These is exceptional. The static is not subject to. Okay, so see this line. Note that this static member definition is not subject to access controls. You can define and initialize the value even if it's declared as private or protected in the class. This is so weird. Okay, I did not know about this. Good that I learned something new. So if you guys were doing this without knowing, then you should know that, okay, this is an exception. And this is an exception. It's not something that, built into the that's because it's very unintuitive, counterintuitive that, how can a private thing be accessed out of the class? Anyway, so yeah. Okay. So this is done. We have made this, and one small thing that I wanted to show you guys is can we do that? Okay, will it require this? Wait, let me see. I'll be quiet. I'll just do this. I'll try to do this. I'll do const complex see. This dot real equals c dot real plus this, and this dot imaginary. This is you're gonna study that if you not know what it's. I'll tell you, don't worry. Let me just finish writing this code first and then we'll write this dot imaginary. This is one of my favorite features of C++. I just want to see if I remember this and it works fine. This is static, static, static. Everything is fine, right? Let's just do. Let's do. So this should return, right? Okay. Okay, so this should return. So this will return a complex. If I don't make it a friend. Okay, so this should also, yeah. I do complex. Okay, so I'll have to make it a friend. Friend. Yeah. So friend complex operator c dot real plus this dot real, c dot imaginary plus this dot imaginary, and then this should return. Okay. Bear with me, guys. 1 minute. I'll just show you what I'm trying to do here. Complex const percent complex const percent. I'll just show you a beautiful thing with C++ you can do, and it's really worth the wait. So complex operator complex const ampersand C1 complex const ampersand C2 down complex dot real plus C2 dot real C1 dot imaginary plus C2 dot imaginary. Okay. Operator plus should work, right? And now let's do one thing. Let's do complex C7 equals C1 plus C2, and then do C7 dot print. Let's just for a moment remove all these print statements. Okay, friend error invalid use of complex variant static member function. Here we have a static member function, line number 15. Okay, no, this is fine. Let me not save this. Okay, let me just compile this again. It says friend complex operator has incomplete type complex. Let's const. Okay. Complex. The type is complex, right? We are not doing any mistakes here. Static int. Do I need a semicolon here? Okay. Well, this is a little weird. Okay. What is the mistake that I'm doing here? Okay, so anyway, let me not waste your time, and I'll tell you what I'm doing here. Actually, what I mean, what I want to do here is, so how is this code? We have done things like this. We have done like C7. Let's say complex C7 equals C1 plus C2. C1 dot add C2, right? Okay. This is one step better than what we have achieved with structures, right? With structures, we would need to call an add function and pass the two structures, and then, but here we get to, we have the ability to mutate the value of the C1 itself directly and add functions inside the classes itself, which can operate on that data. How cool would it be if you could do something like this as well, which I'm not able to do right now because I need to refresh on my operator overloading. But how cool it would be if you could do like this. C1 plus C2, and the C++ compiler is able to understand, okay, you are giving me plus, but you're adding two complex numbers. How do I deal with that? And that's how we define we overload that operator, but somehow it's not working, and somehow I have to revise this. So anyway, I'll not waste your time by showing you something that does not work right now. But I think we'll take a look at this tomorrow, and tomorrow we have to discuss anyway problem solving. So I'll just take around 10 minutes tomorrow to discuss these things that we learned today, and then I will come back to that. So we learned about static, we learned about classes, we learned about structures and how classes came and how the hierarchy started and everything. I think it's been what 1.5 hours. It's almost 2 hours, and I think this is what I majorly wanted to discuss today. We could not solve any problems as such, but I think what I wanted was that you should first understand how classes work, what's the way to make classes, and how static and how just get that mindset of OOP. We discussed about the 4 pillars: abstraction, encapsulation, inheritance, and polymorphism. I hope it's clear to you guys. You don't have to cram it up. It all just makes sense when you start using it also, right? So I think that's pretty much it. I don't have anything else to talk about right now, because I think if I talk more, then it's gonna confuse, as well as I think I need to do things on my part to just take a look at this operator overloading, because somehow I think it's been long that I've done operator overloading, because it's not a function supported in Java. It's C++ specific thing, but it's a very beautiful concept. So I will talk about that later, not today. It's okay. Anyway, anything else, guys? I think that's it for today. Then tomorrow what I'm gonna do is I'm gonna bring some problems. Let's just do a stream of problem solving. The only thing I kind of think before that stream is, what if I could okay, so what we could do is we can okay, what I'm gonna do is I'm gonna come up, I'm gonna maybe send a list of problems, upload I am gonna probably upload a list of problems on my blog or something today evening. Will that be feasible, or shall I just bring the problems tomorrow and just discuss them one by one? What do you guys think? The only problem is we are not connected to the chat, has a little bit delay. So what if I gave you the problems already? You can solve them up and then we can discuss them each one by one, so that I can just take up your doubts rather than waiting for you guys to solve and understand and so on. It's better, right? So maybe I would like to hear your guys' thoughts also. What I'm thinking is, I'll make a list of, let's say, 5 to 6 problems, a good 5 to 6 problems. Let's put them on my blog and we'll solve it tomorrow. I'll just put that in the evening, so you guys have plenty of time to solve those problems. And tomorrow we can come up and then we can discuss those problems. What do you say? Is there anyone who has is any of you also studying data structures or algorithms, or already know data structures and algorithms? Please put your thoughts in the chat, and on that basis I'll do that. And anyone who's watching has not liked the stream, please make sure to do that. If you're enjoying it here and if you're actually getting to learn something, make sure to do that. And subscribe if you haven't already, please. Thank you. And yeah, I'm open to doubts. Please share your doubts if you guys have any. Let me come to the start page. Let me start some music. Not started DS algo yet. Okay, but don't worry, DS algo is not something. I'm not gonna go into the theories. I'm not gonna go into theoretical. Yes, I'm studying DSA. Okay, so Hariket has taken DSA. Okay. So what do you think? Shall I publish a list of a few problems inside my blog, and then we can discuss them tomorrow? My blog link is this. I'll just oh no, that does not work. So HTTPS. Okay, so this should work. So this is it. I think I haven't updated it in some time. So I haven't updated it in some time, but I think a few problems which I solved a few months back on my channel, I think I have solved them. So these pattern problems also, I'm not sure if you have taken a look at that, but these pattern problems, like these kind of problems, are asked a lot sometimes. I myself in interviews have asked some experienced people about these problems. The people really face a lot of problems in solving these kind of problems. So if you haven't taken a look at this, make sure at least go at this and try to take a look at this. I have a part 2 as well on a little more difficult problems. So make sure you at least are able to solve these pattern problems. Maybe I'll include these also. So what do you think? Yeah, that's better, right? Yeah, sure. So I'm gonna do that. I'm gonna publish a list of few problems which I like and are good for you guys also, and then we can discuss them tomorrow. I'll make a stream for tomorrow as well. probably same time or maybe 2 o'clock a little bit later, so that we can have lunch and then aram se we can come and continue, right? So we have to become better, because what I want from you guys is, you guys are still in first year. If most of you who are watching me are in first year, it's the best opportunity for you right now to start problem solving and aim for problem solving contests like Code Force, ICPC and so on. So ICPC is going on right now. It's going to start, and those of you who don't know, don't worry, we'll talk in depth about these things tomorrow, so that it's useful, and please spread it so that more people can take benefit of this. Yeah, so any doubts from today? Anything that was confusing, anything that I did wrong or could have done better? I know I could have prepared a little more, so that would have helped you guys, but apart from that, I think that's something I take on myself. Just checking my voice. Otherwise, then I'll just end the stream and that's all. I think my main idea was to just make you guys comfortable with classes today, to give you the idea of why we are learning classes, and not to feel like, it's another thing that's come up to us and we have to learn it or anything like that. Just think in terms of what was not there already and what we are adding, what's the power that we are getting with classes, right? So all right, I'll just put
Open eye, feel the waves cut through me.
I'll be in the chat, and I'll just put a stream is ending kind of for 10 minutes, so that I'll be in the chat itself. You guys can ask your questions if there are any, and I'll just end this stream then. So okay, actually I rewinded the stream and I saw you that while declaring the friend function you use operator where okay got it. Nice, maybe would have raised it as well. Correct. I don't know why I'm having this habit of using capital, maybe because of a lot of work with Java. Correct Hariket. I think that would have been the mistake. Yeah, correct. Nice point out there. Okay, so can we come there and quickly just show it? Wait. Restart Chrome. Yeah, so can we just quickly come back and do that? Let's see. Friend, we have our friend. Okay, let's try it out. Let's finish it off. I mean, let's just see. It's okay. Those who want to hang out can continue and be here. I'll just solve this out and then end this stream. So we have, okay, so now this is highlighted as well. Nice. Thank you guys. See, you guys know much more than me and always help me. I just love it. So friend complex operator plus, let's try it out. So it says complex add no declaration matches. Okay, so do we have, okay. So this method, are we adding complex add? What's going on? Class complex defined here. Add is not there inside that method, or what? Complex is there. Then no declaration matches complex add. Okay, so I don't return it or what? Okay, so this is a void method. Okay. Yeah. Ooh, so C1 plus C2 3 plus 5 aana chahiye tha. And yeah, we are getting 3 plus 5. So again, I mean, what I was not able to show earlier, thanks to Hariket, I was able to correct the code. So again, I'm not gonna explain, I'm just gonna quickly explain to you. Don't worry, you guys will study if you haven't already. So if you see this, we have used friend, we have used complex, we have used operator, we have used plus, a lot of things in this. So let's just quickly try to dissect it and understand, because it's a very beautiful concept. I really like this about C++. So what I'm doing is, I am defining, I'm overriding the operator plus for overloading, not overriding, overloading I'm making this operator plus do something else when two complex numbers are passed to it. Two objects of type complex are passed to it, and I declare them as const in this function. Well, so these are called operator functions. These are operator functions. This entire thing, operator space the type of the operator, and then in brackets. Almost all the operators in C++ language can be overloaded, except a few of exceptions which you can read, or maybe we'll discuss later. And I use this keyword friend to give this operator access to the private members. So as I told, no one can access private members, but your friend can. So in C++ there's this concept of friend classes, or friend, this is a concept of friend, where your friend can access the private. So if you see here, I could just directly do this dot real plus where I have defined the operator. Yeah, here I defined the operator, so you can do c1 dot real plus c2 dot real. I'm directly calling dot real, even though this is outside the class, but because it is a friend, I can do that. That's why. So this is the reason, and this is how the code looks, and this is how beautifully it works. So see, can you imagine doing this with structures, and see how beautiful code we have got with classes in C++. I mean, this at least should spark something inside you, and you should feel like, oh my god, see, classes are really so powerful, right? We have this beautiful syntax, c7 equal to c1 plus c2, c7 dot print. Imagine in 2 lines, let me just delete these as well. Imagine what this just 5 lines of code is doing. 4 lines, 5 lines of code. It's creating 2 complex numbers. It's adding 2 complex numbers like it was an integer, like it was adding 2 integers, right? So that's how beautiful this is. And you can override minus, equal to, double equal to, brackets. Those square brackets are also operators. You can override that also. So if you see that in vector we can access anything by index, this is overloaded. That's why. But anyway, we'll talk more about that later. Yeah, thanks Hariket again for helping me out with this. And this is what I wanted to show you guys. Yes. So yeah, so I think that's all for today. I'll end the stream here. I'll be in the chat for 5-10 minutes more. You can ask your questions. Make sure to check out the blog today evening around let's say 7 or 8 p.m. I still don't have a community tab because 1,000 subscribers are needed for that, and it's gonna take some time. So I'll just use my blog to publish everything. And yeah, thank you everyone for watching. Thank you everyone for joining the stream. I enjoyed it, and you guys helped me learn something new today. I hope I was able to help you guys learn something new today. And thank you. Tomorrow we'll discuss more on problem solving, a little more different than what we do regularly. Okay, will you be sharing this code? Thanks for the stream. You want this code? Which code do you want? Do you want this code? Tell the function of volatile keyword. Volatile is there in C++ also? Volatile in C++. I know about Java. In C++, is it for volatile? Okay, then I think, because see, in volatile, Java volatile is used whenever you have to guarantee thread safety. Yeah, Satish, I'll put that. So what I'm gonna tell is that, okay, I'm gonna explain volatile in Java terms, and then I think I'll have to read on what it means in C++ because it's a little different in C++. In Java, it's basically simple. If there are multiple, I'm not sure if you guys understand what threads are, so it's a little bit. But I'll tell you what. So okay. Let's say there are 2 copies of your program running and the variables are shared. If this copy modifies a variable while that copy was already trying to read that variable, so this kind of leads to an inconsistency. In order to avoid that, we mark those variables as volatile so that they are always logged. So if someone is editing them, would mean the same. Also extern, and yeah, if you do colon, I'll come back to that. So if you do mark volatile in Java, it basically locks that variable. So while someone is editing it, no one is allowed to read it. While someone is reading it, no one is allowed to edit it. So I think I'll have to take a look at what volatile in C++ means, and also extern and colon. Yeah, so as I said, so if you do scope resolution operator, if you don't provide anything on the left hand side, it tries to fetch everything in the global scope. Yeah, would be in the same axis. Yes. Yeah, that's all. Okay then, thank you everyone for joining. I'll see you guys tomorrow in the problem solving stream. Till then, take care. Bye bye. Let's put this.